Do you feel the vibes?
Hello, grade 8. How are you, everyone? This is Mr. Ahmed Samir, and let's continue with the second lesson of algebra, the set of irrational numbers, and its symbol is Q dash. We learned it before, the set of rational numbers with symbol Q, but the set of irrational numbers with symbol Q dash. Let's start our session. First of all, we studied that the number would be a rational number if it can be written in the form a over b, where b not equal 0. So, from our study of rational numbers, we find that the square root of the perfect square rational number is a rational number, like root of 1. 1 is a perfect square number. 1 over 9, perfect square number. And 25 over 4, by the same way, 0.09. These are perfect square numbers. So the square root of any perfect square number is a rational number. By the same way, the cube root of the perfect cube numbers like 8, negative 64, 0.027, they are rational numbers. But if the square root of non-perfect square numbers, they are not rational numbers. By the same way, the cube root of non-perfect cube numbers, they are not rational numbers. So, we can classify the numbers into rational and irrational. Rational, like set of integers, negative, 0, positive numbers. Fractions like 3 over 4, negative 5 over 7. Decimal numbers, any number has a decimal point like 3.4, 5.6, negative 3.8. The percentage like 3%, 25%. Square root of the perfect square numbers. Cube root of the perfect cube numbers. So we have 6 forms for the rational numbers: set of integers, fractions, decimal numbers, percentage, square root of the perfect square numbers, and cube root of the perfect cube numbers. Examples: 5, set of integer, 0.4 decimal numbers, 25% percentage, square root of 9, and cube root of 27. On the other side, the irrational numbers. We can find the irrational numbers in two forms. The first form, square root of non-perfect square number, and cube root of non-perfect cube numbers. So the irrational number in two forms only, square root and the cube root, but for non-perfect square numbers and non-perfect cube numbers. Examples: root of 2, cube root of 10, root of 8, and cube root of 25. 2 non-perfect square number, 10 non-perfect cube number, 8 non-perfect square number, and 25 non-perfect cube number. So we can find that Q intersect Q dash equals phi because these sets are disjoint sets. Let's see an example. Complete using one of the symbols Q or Q dash. First of all, 3 is an integer, so 3 belongs to Q. Number 2, root of 3. 3 is non-perfect square number, so square root of 3 belongs to Q dash. Number 3, 9 is an integer, and the set of integers are rational numbers. Number 4, root of 9. 9 is a perfect square number, then square root of 9 equals 3. So square root of 9 belongs to Q, rational number. Negative 8 is an integer, and the set of integer belong to the rational numbers. Cube root of negative 8. Negative 8 is a perfect cube number, so cube root of negative 8 equals negative 2. Then cube root of negative 8 belongs to rational numbers Q. 5, an integer, belongs to Q, and cube root of 5 belong to Q dash because 5 is non-perfect cube number. Let's see another important question in the exam. Find the solution set n Q dash. This is a condition for the equations n Q dash only for each of the following. First of all, 2x power 3 minus 7 equals 3. To solve this equation, we will translate negative 7. We will move negative 7 to the right side by inverse operation. So it will be positive 3. Then 2x power 3 equals 3 plus 7, 10. Now we want to remove 2 from the left side. We will move it to the right side by inverse operation. It will be 10 divided 2. So x power 3 equals 5. The inverse operation for x cube or power 3 is the cube root. Then x, it will be cube root of 5. The number cube root of 5 is a rational number. Then the solution set will be cube root of 5. The second example, have x power 2 minus 5 equals 3. Let's translate negative 5 to the right side by positive 5. It will be 8. Dividing by half, then x power 2 equals 16. The inverse operation of power 2 is positive or negative square root. Again, the inverse operation for power 2 is positive or negative square root. Then x, it will be positive or negative square root of 16. It will be positive or negative 4. In this case, positive or negative 4 is rational number. But we have a condition here. The solution set have to be irrational number. Then in this case, the solution set, it will be phi. Another important question, an equation consists of two brackets, x power 3 plus 5 multiply x power 2 minus 3 equals 0. First of all, we will suppose that one of them equals 0. Then if x power 3 plus 5 equals 0, or x power 2 minus 3 equals 0. Let's see. Then assume that x power 3 plus 5 equals 0 or x power 2 minus 3 equals 0. And we have two equations now. The first one, x power 3 plus 5 equals 0. Then we will translate positive 5 to the right side by negative. It will be 0 minus 5 equals negative 5. The inverse operation of power 3, it will be cube root of negative 5, and it is an irrational number. By the same way, x power 3, x power 2 minus 3 equals 0, then x power 2 equals 0 plus 3. Then x power 2, it will be 3. The inverse operation of power 2 is positive or negative square root of 3. This number is an irrational number. Then the solution set will be cube root of negative 5 and positive or negative square root of 3. Thank you for listening and wait for the next session, inshallah.